and fill out some. I guess I need to probably prepare some paperwork for the possible copyright infringement I've got going on here. Yeah, unfortunately, I can't. It would not be feasible to do Dr. Doofenshmirtz's voice the entire class. Um, all right, so all right, so let's go ahead and say yeah. Okay, so boom, boom, boom. Close that. Minimize this, and we are going to share my screen, which unfortunately means that now I'm a even smaller thing, but that's okay. So we are going to now. So today, what are we going to work on? We are going to work on. If we go down to module 5, we are going to again we click on this module over here to tell what we're going to be doing. Again, we're really hammering down on the for loops in preparation for next week. We've got some items over here where we're going to be talking about for loops and conditionals and stuff like that. We go over the conditionals are on the exam a bit, but you really don't have to write if else statements, just true or false. Today we are going to work on some programs I used to give as homework for week 5 or week 6, and yeah, we're gonna work on what used on old week 5 homework when I just before I realized, oh, I should give a bigger assignment over 2 weeks to make it more worthwhile. And then on Thursday, that is another fun exercise. Um, and that is a exercise that involves no loops, and yet it is uniformly difficult for basically most beginning programmers. In both these cases, you'll be uploading your assignments over here into the Dropbox. I'll be checking for uh basically completion, not necessarily for accuracy. So basically, did you participate? So I will go ahead and drop this in chat for everybody. The Linkinator. Okay. So now if we go over here, um, we've got our intermediate uh um loop problems, which we're going to use to go over if statements, which we've seen briefly, but we're going to actually use them. Okay. And basically, these are intermediate loop problems that will basically mix if statements and for loops. They're beyond the difficulty of what will be going on during the exam, but I think they're pretty darn good ones. So, write a function given a string returns the total number of vowels that were in the string. So this actually is great because we are going to be doing so very much here. So very much. Also, just FYI, for everybody who's here, I have asked this question or some variation of it on the second exam. Okay. So just FYI, all right, that's kind of a valuable thing to know. Okay. Next problem is checking how many even digits we have, then doing 3-digit Armstrong numbers. So let's first off tackle this one at a time because we are being asked to do a lot. The first is write a function that. So let's talk about functions because we really haven't before. Okay. Python is a language, and like all languages, it is made up, completely made up, right? Just how Dr. Doofenshmirtz makes a bunch of innators throughout stuff, and you instinctively know what they are based off of just the use of English language, you can make your own stuff up, and people will hopefully instinctively know what they are. So, the Python programming language is already composed of plenty of of nouns like our numbers. We just need to submit it. So, like for instance, over here we can say num is equal to 10, and we have a defined noun. We have our basically our 10 over here, which we can basically print out. Our number over here. Okay, where's the word print over here? This is a verb, right? So we've got our noun over here, and we've got our verbs. Print is a verb. It's a function. It prints things out. You can tell something is a verb because we have parentheses being used here, right? As a function, just like how a function in math, right? Function in math, you would have f of x, and that's how you know f is a function, right? Makes sense? Right? And x is a variable because it doesn't have parentheses. That is the same principle here in Python. So for instance, in math, you might have f of x, g of x. In Python, you might have print x or spam eggs in Python talk, right? So here we go. So the question is, if this is a language, how do we add our own words to it? So functions, again, are going to be our verbs. Okay? And functions, depending on the language, might go by other names. They might be known as procedures, or they might be known in object-oriented language as methods. You may have heard this term before, method. Functions, procedures, methods, they have formal definitions, but most people are going to understand what you mean if you interchange them. They are most closely analogous to verbs in our language. They do stuff as opposed to nouns, and which are stuff. Right? Now, we are going to learn how to make new functions. What about making new nouns? Those are objects. And we have an entire class dedicated to that. That is CIS 1068. Object-oriented programming. So it's a big enough topic that we've dedicated that basically every university dedicates an entire class to it. Whereas this is this class. So we're going to start getting into the habit of writing functions. Now, if you checked out the exam, you're not going to need to write too many functions. Those functions are kind of already going to exist. All right. So let's go ahead and write a function. Okay. A function basically is at the core just simply a command. It starts out as follows: DEF for define function. And let's go ahead and I'll just simply call it print5. Okay. And this just simply, so I say def print5, and then I use parentheses to say, hey, this is what you need to do, what print5 needs to do in order to run correctly. It needs it needs nothing. And then you have a colon, which says everything that's inside this function, everything that's indented is part of this function. And I'm going to just make it very simple. For for in range 5. So this is a loop that runs 5 times. Print hello. And that's it. That's all I need to do for, and a function can basically be as long as it's at least one line long, it can be as big or as little as I need it to be. And you've seen this already in your assignment. A bit. So print 5. Hello, hello, hello. And now if I run it again, I'll get 10 hellos. Okay. Now I can alter that. I can make a new function by writing in more defs. Def print hello x, which will take in a number. You can call this variable whatever, but now we are saying we are taking in one variable. It is called number, which says to any other programmer who's reading this, that's probably a number. Be a real jerk move for it not to be a number. So for blank, and note the difference here. Here, print 5, we just didn't have anything in the parentheses and it printed out 5 times. Here, if I replace this 5 with number, it will print out number of times, like so. Print hello x. And if I don't do anything, it's going to yell at me saying, hey, print hello x missing one positional argument, number. Make sense? It says, hey, you promised me a number, you gave me jack diddly squat. So if I give it 16, this goes into here. This gets copied from here to here. And then this loop runs a grand total of 15 times. I'm sorry, 16 times. Make sense so far? So hopefully my videos have gone over these concepts. Yes, no? I believe, yes, no? I want to make sure I'm not like skipping too far ahead here. Okay. Yeah, taste of functions. So it should have been, yeah, we should have been, we should have seen this. Yeah, so we should have seen this hopefully. Functions, yeah. So you should have seen a few of this with a few of these invocations and parameters as to how these work. Okay. Now, so with that, let's go ahead and work on our function numvals. Def numvals. And that is a function that is going to take in some kind of text or word or whatnot, given a string, returns the total number of vowels that were in the string. This other term, return, is important. I'm going to go ahead. What return does is effectively, when we print out something, that's just kind of going to go over here for the computer to look at. Not very useful for the computer, right? If we want to use it as part of a calculation or something. Okay? So what we do instead is we can use a statement. We use something at the end of a function called return, which basically says, this is the answer for whatever calculation I'm doing. So over here, if I do numvals, I'll basically say, I'll create a variable called count is equal to 0. And I'm going to return that count, and then I'm going to do stuff. And then I'm going to return count at the end. And the benefit for taking this kind of approach to doing it is I can already start running the code and getting wrong answers. Yes, wrong answers are sometimes valuable. So if I put in blah, 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 right over here, I'll get 0 because the count is 0. If I put in, oh, count starts at 1,000, I'm going to, or 100, I'm going to get 100 vowels because that is what I've returned. This, when you return something, it basically replaces the function call, this invocation, with whatever you're returning. Now, to see why this is useful, I'm actually going to skip ahead and say, and show you one of the advantages of writing things as functions, which is that you can break things up into multiple tasks. So basically, what I've got here is a function that's going to go through all the numbers and ask if it's a vowel or not. Sorry, all the letters and ask if they're a vowel or not. And if they are a vowel, I'm going to increase the count. So what I'm going to do first to make things a bit easier for myself to focus in on a smaller problem is I'm going to write a separate function. Def is val, which takes in a letter. And then it's going to tell me whether that letter is a vowel or not. Now we can do this with with a few different ways, actually. Okay. Now, if you've been reading your book, there's a few different ways, but what we're going to do over here is I'm going to go ahead and show the if statement. If letter equals A, or letter equals E, or letter, and then I'm just going to copy paste this bit. Okay. Or, whoops, or letter is equal to E, or letter is equal to E, or letter is equal to E. U, O, I, A-E-I-O-U, right? Do I have edit format option configure idle? Do I have word wrap? Do you do word wrap? What a shame. No word wrap. Okay, that's fine. So anyway, we have the statement here. If the letter equals A, or the letter equals E, or the letter is equal to I, or it's is equal to O, or the letter is equal to U, that means it's a vowel. So the nice thing about logical statements like this is that they're fairly easy to read, even if they are a bit, how to say, long, right? It is A, E, I, O, or U. Also notice that the way I did this was not A or E or I. This is wrong. This does not produce the desired results at all. We'll go more into that later. But basically, you need all these separate statements. And this will tell you whether something is a vowel or not. Right? Let's go ahead and test it. Print is vowel. And I'm going to test it on A. And what about B? False. And L and E, true. What about capital E? It's false because that's not one of the ones we specified. There's ways around that. We're just going to assume, though, for the sake of argument, I just care about lowercase letters. We can deal with this in a second. Okay? Um, but this is only one of many ways to do this. We can also do this in just one statement. So we can also just do this in one line. Since this is a statement, and if it compiles to true, if it evaluates to true, we return true. And if it evaluates to false, we return false. We can just skip the if else statement and just simply say return this statement, which is a bit advanced. And even I don't like the way that looks. What I do like the way it looks is a even shorter statement. There's a few other ways you can do this. Return letter in A, E, I, O, U. And that is a question, and the in operator is amazing. So the in operator is not just part of the iteration, it can be used as a operator to ask if something's in something else. So for instance, I can ask if E is in AEIOU, which it is. What about F? Or I did E. What about A? True. So it all just so this makes it so this is even shorter. And it's a very Pythonic way of doing things. Now, why did I bother going through all of this? Okay. Why did I bother going through all this and make isVal's own function? Because you can have functions call functions, right? Verbs can be a description of doing other verbs, right? So let's go ahead and go to numVals. And what we're going to do is we're going to say for letter in text. If is val letter, so this is the function we just wrote. If we get true back here, then what we're going to do is we are going to do count count is equal to count plus 1. Okay. The important thing to note here is that there's not necessarily, we don't really need an else. Okay. So, right, there is no need for an else. You just don't do anything if it's not true. Okay. So here we have help, I am trapped in this program. And we have 1, 2, 3, 4, 5, 6, 7, 8 vowels. And we do have that I, which should be counted as a vowel. Now, I don't know about you, but I don't want to add 5 more conditions over here. Do you? No? So what we're going to do is very simple. We're going to add one more line and say letter is equal to letter dot lower to turn it to lowercase. Is everybody following along? I'm worried that people are not following along because I am getting a very distinct lack of questions. Well, that was a weird look, Dr. Doofenshmirtz. That what you did with your eyes there. It was like, yeah, kind of like that. only more stoned looking. Ah, all right, good. All right, so that's how we count the number of vowels. It's fairly straightforward. The second one is very, very similar, except it's not. It's a very, this is another one that I love asking in exam too, or something similar. Number of even digits. Write a function which, given an integer, returns the number of even digits in an integer. For example, if the function is passed 254, you should return 2 because they are two even digits. You'll need to use modulus and division to solve the problem. The strategies used here will help you develop solutions to the next problem. So I actually am lying here. You don't need to use modulus, technically speaking. That's just the way I would want you to do it if it was homework. Okay, because here's kind of the idea here. All right. So first off, let's go ahead and ask, how do we tell if a number is even or odd? And I'm not going to bother writing a separate function for that. I'm just going to go to our shell. Okay, and what we're going to do is I'm going to show you that basically we could, you know, we can simply say like a number, like num is equal to 40. If we ask num mod 2 equal 0, this mod 2 equal 0, oh, come on. Num mod 2 equal 0, that tells me whether something is true or false. So let's go ahead and explain what's going on here. When I do a number mod 2, I'm dividing it by 2. But what I'm getting back is not the quotient, but the remainder, right? 50 divided by 2 has no remainder, whereas 51 divided by 2 has a remainder of 1, right? It's only, right? When you divide by 2, it's either 0 or 1, right? Makes sense? Nothing up my sleeves here, which I can't show you because this model doesn't support hand tracking. So, anyway, we are going to go ahead and use this fact to tell whether a number is even or odd, right? If a number is divisible by 2, if it cleanly divides by 2, there's no remainder. That's what it means to be an even number, to be a multiple of 2. Okay? Whereas if we divide a number by 2 and there is a remainder left, well, that tells us that is an odd number. Make sense? So we take this bit, we add 0, 0, we add equal to it to do a comparison, and we ask, hey, is the number on this side equal to 0? Right? Is this over here equal to 0? If it is, that'll be a true. If it's not, return false. Give me false back. Okay. So we can use this to tell whether a number is even or odd. Okay. Now, the next question we have to ask is, how in the world do I check every digit of a number? Def, num, even digits. We're counting the number of even digits in a number. So let's go and start by printing out each digit one at a time. This is not the problem we needed to solve, but it's a problem we need to solve on the way to solving the problem. So why not? So your first instinct is probably to try something like this. 4 digit in number, right? Print number. This is our first instinct, and it's not a bad instinct, even if it is completely and utterly incorrect. Num even digits, 782, right? And we'll get a error saying type. Here's the error. It tells me what line it is on. Now, it does tell, now over here on the bottom, it's hard to see. Here, give me a second. Oh, let me draw my screen for a second. Over here on the bottom right is an indicator of what time, sorry, not what time, what line everything is on. Let's go ahead and make that a bit easier to find. Go to top. I'm going to go to options, and right below configure idle, show line numbers. And now we have the line numbers on the side, like a proper IDE. And show code context on top. Nice. Okay. So Now what we're going to do over here is we are going to say, so we have the num even digits over here. How do we iterate over this line? It says that we can't iterate over an integer. That makes sense. How there's no most obvious way to do it. So there's two ways to do this. The first way is to cheat. The second way is the way that I intended it to be done. So what do I mean by cheat? Well, we can take any integer and we can convert it to a string. Okay. And by doing that, well, we can technically iterate over it like that. But we don't want to print out the whole number. We want to print out the individual digit. That is not great. Because converting can be expensive. Also, it takes time to. Not only am I going to have to convert this number into a string, I'm going to have to take the string and for every digit, I'm going to have to take that and convert it back to a number if I want to do mathematical operations on it. So, not exactly the smartest move, the most clear and powerful move. Instead, the other option we have for doing iteration on this problem is we are going to use a while loop. Okay. While this is occurring, basically it's a if statement that keeps repeating from the top to the bottom as long as it's true. I want to emphasize that the majority of the there are not going to be necessary if statements and while statements on exam 1. Okay. This is here because I like to push. Okay. While, and this is a bit tricky, and so I'm going to just go ahead and show you. While number is greater than 0, here is what I'm going to do. I am going to say, I'm going to use modular arithmetic. I'm going to say the current digit I want to look at is equal to number mod 10. What does that do? Well, a bit of a trick here. I mentioned very early on in like our third lecture or so that basically we could use mod 10 as a tool. I could take any number, mod it by 10, and I'll get the rightmost digit. Make sense? And another trick I can do, I can divide any number using integer division, divide it by 10, and that throws away the last digit. So I'm just going to do this again and again. Okay? So, while while the number is greater than 0, what I'm going to do is I'm going to take the rightmost digit, which I'll just call digit, by taking that number and modding by 10. Then I'm going to need a count equal to 0, return count, the number of times I'm counting this, we're doing this. Okay? And while count is equal to 0. Sorry, while number is greater than 0, we are going to basically ask if digit mod 2 equals 0, if that digit is even, count plus equals 1. And then what we do is we say number is equal to number mod 10. Like that. So that will throw away the rightmost digit. And if we do even digits, we run it and it doesn't print out anything because I didn't tell it to. When you return something, you have to do something with it. In this case, I'm printing it out. And we see that this has 2 even digits. So 777272222. Right? And there we've got 6 even digits. the next problem is checking if a number is a 3-digit Armstrong number. Okay. Oof. I'm apparently getting much more tired than I thought I was. All right. Def. Armstrong. Why do you have to do number is equal to number divided by 10? Excellent question. So what this does is that this is if I didn't do this, the number would remain the same every time I was every step of this while loop. Okay? Number needs to if notice the equal sign means we are assigning a different value to number. Without this statement, we would just simply be taking the rightmost digit of number but not taking it off. We'd be retrieving the rightmost digit of the number. Okay? We'd be retrieving the rightmost digit of the number, checking if it's even, and then doing that again and again. What this does, when a number is divided by 10, that gets rid of the ones place. So number divided by 10, we take the number, get rid of the ones place, and store it back inside number. Make sense? Mm-hmm. It's weird to kind of I mean I barely think of it as dividing by 10 almost because I look at that and say gets rid of the rightmost digit in this context. It's a bit weird. Now, yep, and it does it until the number is equal to 0. Once the number hits 0, that's how it knows to stop counting. Be right back for a second. Okay. My kid's in the couch on the other side of the room, so I just wanted to check on it. He's tired and cold. Fevers, you know? All right. So let's go ahead. So 3-digit Armstrong numbers. Armstrong numbers are these weird numbers where the cube of each of the digits of the number is equal to the whole number. So over here you have 371. That is an Armstrong number because 3 cubed plus 7 cubed plus 1 is equal to 371. And don't take my word for it. 3 cubed, 7 cubed. I don't think I need to do 1 cubed for you guys, right? So 3 cubed plus 7 cubed plus 1 cubed is equal to 371. Right? So that is a 3-digit Armstrong number. 370 and 371 are both Armstrong numbers. So we're going to write something to check if these are Armstrong numbers. Okay. So once again, we're going to basically use a lot of the same strategy as we did for this previous one. Def is Armstrong num. Taking a number. And what we'll do is we will say basically its total is equal to 0. And now we have to iterate through each digit. We know how to do that. While number, or we've just learned how to do it rather. And while number is greater than 0, the rightmost digit is equal to number mod 10. Okay, yep, I'll fix that in a second. Number is equal to number mod 10. And then total is going to be equal to total what our previous total is, plus digit cubed. Right, we're going to cube that digit. And then we get rid of the last digit. Number is equal to number mod, not mod, divide by 10. And then what we'll want to do is basically return if number equals total. Now, if we do this, however, we're in a bit of a bind. Why? Because we're modifying number until it gets down to 0. And then we're trying to compare the original number, right? Does that make sense to everybody? See how this would always be false? Because what we've done is we've gone through and we've modified the number at every step of this. Now, this is an easy fix, though, fortunately, by just simply copying our data. Original is equal to, so one way to do it is basically copy over your original number and do it over here. The other way is to copy number into some temporary variable and then replace it over here. Is Armstrong number 277 is not an Armstrong number, whereas 371 is an Armstrong number. All right. This last one I think is a bit the most fun, is probably the most fun. This comes from the Java textbook I initially used for this class when it used to be 1068. We changed up how the curriculum was presented a couple years ago, a number of years ago actually. And so anyway, this was from that textbook. Holy Digits Batman. The Riddler is planning his next caper somewhere on Pennsylvania Avenue. In his usual sporting fashion, he has left the address in a form of a puzzle. The address on Pennsylvania is a 4-digit number with the following properties. All 4 digits are different. The digit in the thousands place is 3 times the digit in the tens place. The number is odd, and the sum of the digits is 24. Write a function that uses a loop or loops that returns the address where the Riddler plans to strike. All right. So our first key here, and I'm going to give you a bit of time after having messed with these kind of things over here. Def Riddler. This one takes in no arguments because it's just going to run the same no matter what. But what we're going to need to do is we're going to need to calculate. We need to check that all 4 digits are different. We got to check the digit in the thousands is 3 times the digit in the tens. We got to check against the number being odd, and we want to check if the sum of the digits is 27. So we're going to need each of the 4 digits of this individually. So let's go ahead and just kind of be a bit good here. For number in range, right? It's a 4-digit number, so we know it's going to go from range 1,000 to 10,000, up to but not including 10,000, right? And what we need to do is that we need to get the ones place, the tens place, the hundreds place, and the thousands place, right? Each of those individually. All right, so take a few minutes to figure out, given a number, a 4-digit number, how do I get each of those pieces individually? Okay, a couple minutes since we do have plenty of time. finish up my lecture soon. Okay. Yes, you would be using mod 10 to do this, but not just mod 10. So, the interest of me getting this done before I collapse from exhaustion, I'm going to go ahead and just proceed to get this done. All right. So first off, let's go ahead and boot up. I'm just going to go ahead and window, boom, 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 Python shell. Okay. If I have a 4-digit number, we kind of have already learned how to get the ones place of it because we know how to get the one place of any number, which is mod by 10. Okay. On the reverse, it's been a while, but you do know how to get the digit of a thousands place number. 5342. If I want that 5, I'll just divide by 1,000. Make sense? Right? If I divide by 1,000, that's kind of the same as throwing out those 3 digits over there, right? Because, or another way to think about it, 45342. We threw out we threw out the ones place, then we threw out the ones place, then we threw out the ones place. Same as divided by 1,000. So now, what about the tens place? Right? 5342. If we mod by 1,000, sorry, mod by 100, we end up with 42. Now, while that is the answer to life, the universe, and everything, it is not the answer to this question. Right? So here, though, we do have 42, but it is getting closer. If we can get rid of this 2, we're in good shape. So what we can do is we can mod by 100, and then what we'll do is we'll say 42 divide by 10 to get this digit. So thinking about them in terms of operations, right? So now let's go ahead and fill this in. So to get the ones place, it would be take a number, a 4-digit number, mod by 10. To get the tens place, take the number and reduce it to just simply the last 2 digits, the tens and the ones place, and throughout the ones place. Another way to do the tens, though, 5342, would be to divide by 10 to get this, and then mod by 10. Right? Throughout the ones place, get the ones place. So, divide by 10, mod by 10. And we can use that same approach for the hundreds. Divide by 100 to get rid of these 2 digits, and then mod by 10 to get the new ones place. And we could follow this pattern over. We could basically just follow this pattern now that we see that there is a pattern. But effectively, this is the same as divide by 1,000. And again, we could follow this pattern over here, but dividing by 1 gives you the same number. Sometimes it's really cool. You can find patterns where you didn't expect them to be. Okay. Now, again, I'm going to go ahead and speed this up. So first thing we want to do is check, are all these digits different? So what we're going to do is we're going to basically say, hey, we're going to print out numbers, and we are going to try that. Why is the range 1,000 to 10,000? Because we're looking for a 4-digit number. And this is the range of all 4-digit numbers. So now we want to check, are those digits different? This is the most tedious and awful part of this, which is basically what we're going to do is we're going to say if ones is not equal to tens and ones not equal to huns and ones not equal to thou. Now you know why I did it as 4 letters for each of them. And so we've checked ones against tens, hundreds, and thousands. So now we need to check tens against the other ones. And tens is not equal to, we don't have to check against 1 though, because these two statements, checking if these two things are different, that's the same question, just reversed. So we can skip directly to tens is equal to 1 huns and tens is not equal to thousands. And then we just need to do huns not equal to thou. Okay. So now let's print out all the numbers where that qualifies. That's going to be a lot of them. But we're going to see that it gets rid of some. I should probably, of course, it's not going to print out anything if we don't call it. Second time I've made that mistake today in front of you. So we go, and notice it skipped all the numbers that would have started with 11. We'll notice that we're going to skip all the numbers that start with 22. So let's go ahead and terminate this process because it takes a while. So next, what are the other qualifiers? The digit in the thousands place is 3 times the digit in the tens place. The number is odd. We can actually tackle this one without any if statements, just by clever programming over here. By saying, hey, we're going to start at 1,000 and go up by 2s. Now we're only going to do odd numbers, right? Okay. The digit of the thousands place, okay? So we're going to make another one. If the thousands digit is 3 times the digit in the tens place, is thou equals tens times 3. Let's go ahead and print. So digit in the thousands place is 3 times this one, right? 3 times the tens place. Digit in the thousands place, 3 times the digit in the tens place. The number is odd, and now the sum of the digits is 27. If ones plus tens plus huns plus thou equals 27. And we get 9,837. Which honestly is not a very good riddle. Maybe if he had used a riddleinator, he could have come up with a better riddle. All right. So, with that, we have done our 4 problems. I think I'm just going to be nice here. Stop sharing. And I'm going to go ahead and send I'm going to drop the file I just created in chat. And I guess and so you can upload that file and get credit for it. And I guess everybody the half of the students who didn't show up are going to have to basically redo this by themselves. Um so you may have had um you may have not equals. It's not just exclamation point, it is not equals. Yes, Alex.
So we're uploading this to loop and function exercises.
Yep. What day is the first exam? Excellent question. When is your That depends on your lab. If your lab is on if your lab is on Friday, your exam is on the 20th. If your lab is on Monday, your exam is on the 23rd. If your exam is on So this is week 5, it'll be in your week 6 lab, which is going to be the 20th for Friday labs and 23rd for Monday labs. Yes, we are doing Blame Pope Gregory the 13th on Thursday. All right. With that, class is dismissed. I'm going to go take care of my kid and get some rest.
All right. Bye bye, Dr.
Thank you.
Doofenshmirtz.
Thank you.
All right,
Thank
have a great
you.
day.
Bye.
Thank you.
See you on Thursday.
See ya.